So make sure you know these, because they're important. Okay, your special right triangles. Short leg is x, long leg is x radical 3, hypotenuse is 2x for the 30, 60, 90. The 45, 45, 90, both legs are the same. Hypotenuse is the leg times square root of 2. All right, let's take a look at the unit circle now. All right, unit circle. I want to deal with the first quadrant first. Okay, so if you look at the first quadrant, let's deal with the coordinates that are simple. Does anybody know why it's called the unit circle? Yes, it deals with the measurement. The reason why it's called the unit circle is because the radius of this circle is 1. Hence the term unit. It's 1 unit. So the radius is 1. So all these measure 1. Because all the way around, they are just simply radii on the circle. Okay? So if that's the case, now we want to think of it as an xy plane. If that's the case, what is this distance over here? We know this is the origin, right? That center point. So this would be 1, 0. And what would be right here? 0, 1. And so on and so forth on the other sides. Now, what is the measurement of this degree if we start here? 0. The wide spaces are 30 degrees and the small spaces are 15. Okay? Questions about that? Wide space is 30, small space is 15. So from here to here, how far did I go? 30 degrees. From here to here, I went 15 degrees, right? So it'd be 45. Small spaces are 15 degrees. The next one, I'm going to add 15 more. That gives me 60. And if I add 30 to the next one, it gives me 90. Okay? Any questions about that? We'll get there. We'll get to that next. All right, so let's go ahead all the way around. What would be the next one? 120. Next. Next. And the next one? 180. Okay? And we'll go all the way around in a second once I finish this top half. Questions about that? Now, the next part, we convert it to radians. So we know this has to be 0 as well. Convert 30 degrees to radians. 5 over 6. 45 degrees to radians. 5 over 4. 60 degrees radians. 5 over 3. What did I tell you 9 degrees was? We did these on the graph. The 5 over 2. 120. 2 pi over 3. 135. 3 pi over 4. 150. 5 pi over 6. And 180. It's just pi. Okay? So far, this is not hard. Is it? No. Huh? 5 pi over 6. Okay, so now let's deal with the other coordinates. Because this is where most people get the most trouble from. Dealing with other coordinates. Okay? So, to deal with this first coordinate right here, we're going to create a triangle inside this unit circle. Created a right triangle, right? Mm-hmm. Now the distance to that coordinate, we're going to go right, an x value, and then up a y value, correct? Everybody okay with that? Okay. So if this right here is 30 degrees, that means this angle is 30. Right? Because from here to here is 30 degrees. Yeah. And this has to be 60 degrees. Correct? What's the hypotenuse of that triangle? It's 1. The hypotenuse is the radius of the circle. Okay? Right? So that means, if we know that's true, the hypotenuse equals 2 times the short leg. Y. Correct? So my y value equals 1/2. My y value is 1/2. Well, if that's the case, my y value is 1/2. My long leg equals the short leg times the square root of 3. Right? So x equals 1/2 times radical 3, which is radical 3 over 2. You're halfway done with the whole unit circle. Any questions about that? You only have to find it for the first 2 coordinates, though, because I'm going to teach you how to do the rest of it really fast. Okay? So, let's look at the next part. Any questions about that before I go on to the next one? Does that make sense, what we just did? Okay. So, for the next one, we have another triangle. Well, in this one, it's 45 degrees. 45 degrees. So it's a 45, 45, 90. Okay? Now ignore the stuff in blue because I'm going to do everything with this one in green. So just ignore the stuff in blue, okay? So again, to get to this coordinate, we go over an x value and we go up a y value. Well, according to this one, x and y have to be what? X and y will be the same because it's a 45, 45, 90. Okay? So, I know the hypotenuse is 1, right? So it has to equal one of the legs times the square root of 2. So divide by the square root of 2. So x equals 1 over radical 2. And if I simplify that, what do I do? We would just move the radical to the top, remember? So what does that become? Radical 2 over 2. But I know x and y are both the same. They're both the same. You haven't done anything incredibly hard yet. And you won't. Because that's the most work you have to do with the unit circle. So, to find that last one, what is this angle? 60. What is this one? 30. Didn't we just solve a 30, 60, 90 triangle? What happened to this one, though? It just flipped directions. So if the triangle flipped, what do you think happens to the coordinates? The coordinates flip. So there's no work to do for the third one because I've already solved it. Okay? Now all the work you just wrote down, when you do the unit circle quiz, that's what you have to show me. You can't just fill in the unit circle. Okay? You have to show me how we utilize the triangles to find those first 2 coordinates.
We're going to have the same answer.
Yeah. Yes. Right. So you have to know how to replicate what I just did and solve it. Okay. All right. So now I can teach you how to find the rest of the coordinates on the unit circle. So I'm going to shrink this back down. Okay. Look, kind of small, but can everybody see that? Okay. Okay. Now this is about to be the easiest part of this process. First quadrant. What are the signs of the first quadrant? The x and y coordinates are signs. Positive or negative? Both are positive, right? What's the signs of the second quadrant? Negative, positive, right? X negative, y positive. Signs of the third quadrant. Signs of the fourth quadrant. Positive, negative. Apply that concept to all the coordinates, okay? Straight line, change the sign. Straight line, change the sign. If I draw a straight line from this coordinate to this coordinate right here, or this point to this point, they're going to be the same x and y values, just different signs. So we still have 1/2 radical 3/2, just my x is negative now. Okay? This one, and straight across, because what I'm doing is I'm literally going straight across and changing the signs. Straight across, change the signs. Straight across, change the signs. Okay? Because everything is mirrored from the first quadrant. Now, if I want to fill in this one, it forms a straight line to that coordinate. So it's the same coordinates, just change the signs. So this one down here would be negative radical 3/2, negative 1/2. And guess what all the middle ones are? The middle coordinates of the quadrant, the middle of the quadrant. Like all of these. They're all radical 2/2. The very middle of each quadrant is always radical 2/2. Always. And the degree always ends in 5. And the radian always has a denominator of 4. Okay? So the next one, this one, oh Lord. This one right here is 1/2, negative 1/2, negative radical 3/2. And what are all the denominators? 2. All the denominators are 2. So right here, straight line all the way down, 1/2, negative radical 3/2. Radical 3/2, negative 1/2. See how quick it is to fill in all the coordinates? Nothing hard about the unit circle. No, I do like 30. Most people finish it like 10.
Is that Monday quiz?
No. You have 2 separate quizzes for this unit.
Mr. Cobb, you can make a video doing that, trying to look farther, like you stop studying.
Yeah. All right. So what's the coordinate that goes here beside pi? What's the coordinate down here at the very bottom? Okay. Let's fill in the rest of the degrees and radians real quick. So after 180, what's the next degree? 210. Next after that? Next. 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 And finally, 60. Let's fill in our radians at 210. Not so quick with this one. 7 pi over 6. Next. This one's 5 pi over 4.
Yeah.
Next. 4 pi over 3. Next. 270 is 3 pi over 2. 300. 5 pi over 3.
Is that 7 pi?
7 pi over 6. 315. And 330. 11 pi over 6. And 360 is 2 pi. And that is the whole unit circle. And how to solve it in the first quadrant. If you don't show me those triangles in the first quadrant, it's automatic 0. You get no credit at all.
Not even like 1 if you thought.
You could fill it out perfectly. I will still give you a 0. If you don't show me those triangles and how to solve for the first quadrant.
When is the first one?
Probably Tuesday. It will be Tuesday. Beginning of class Tuesday. But all right, any questions about this? All right, so the next thing, if you want to identify a trig function from the unit circle, let's say you want to know the sine of 45 degrees. It's your y coordinate. Okay. Shift this aside a little bit. Sine is your y coordinate. Cosine is your x coordinate. Tangent is y over x. You guys already did. You wrote them down in your notes from Unit 6. Remember y over r, x over r. R in this case is what? 1. R is 1. Okay. So, what is the sine of 60? Radical 3 over 2. Okay. What is the tangent of 135? Seriously?
81.
Nope. Tangent of 135. Thank you. -1. Don't use the calculator next time.
Oh, okay, did I negative?
One of them is negative, so a negative divided by positive is okay.
I mean, I was thinking about it just canceling out.
It's -1. Because what is anything divided by itself? 1. And 135, the coordinates are the same, right? So radical 2 over 2 divided by radical 2 over 2, which is 1. But since one of them is negative, it's -1. All right. What is the cosine of 315?
Radical 2 over 2 over negative.
Cosine of 315?
It's radical 2 over 2.
It's just radical 2 over 2. Okay. What is the cosine of 4 pi over 3?
4 pi over 3.
-1/2. -1/2. Okay. So any questions about that?
No.
All right. So you're gonna have a test on that as well, identifying the values of trig functions, and you will not be able to use the unit circle.
Oh, I thought you said.
And you won't be able to use a calculator either.
All you gotta do is just divide probably 80 and then convert it to a fraction.
Wait, so we can't use a
No, you have to do the sine and cosine of different angles from the unit circle, and you won't be able to use the unit circle, nor will you be able to use a calculator.
So we're gonna fail.
So you need to commit this to memory.
So we have to memorize all the like
Yes,
fractions.
Well,
Wouldn't you only need to memorize the first three and just know of the
pretty much. Because guess what you can do?
Write it out.
You can use a reference angle.
Well.
Okay. What's the reference angle for 225? No, let's do it different. What's the reference angle for 210? The reference angle for 210. Reference angle. What you just did in your notes. How do you find the reference angle? It's in the third quadrant. You subtract 180 from it. So what's the reference angle for 210? 30 degrees. Do you know the coordinates for 30 degrees? Okay, what quadrant is 210 in? So make the appropriate sign changes. Exactly. So if you can find the cosine of 30 degrees, you can find the cosine for 210, just apply the appropriate sign change. Okay. What is the reference angle for 120? 60. Aren't the coordinates for 120 and 60 the same, just different signs? Okay. So if you can find the reference angle, you can apply the coordinates of the reference angle and change the signs appropriately depending on what quadrant it's in. Anything that ends in 5 will always just be radical 2 over 2, radical 2 over 2. Not anything that ends in 5, but any number on the unit circle that ends in 5.
Okay.
So 45, 135, 225, and 315 are always radical 2 over 2, radical 2 over 2. It depends on what quadrant it's in. Yeah. And notice that all the radians divided by 4 are the radical 2's over 2's. Well, see, there's so many different tricks to help you remember all this stuff. Okay. There's the hand rule. I don't know it, and so I don't teach it. So if you Google, there's a hand rule for this. I just don't know what it is. I'm not wanting to learn it either. So, because I feel like my method of learning it is easy. So, any questions about the unit circle?
No.
Okay. That was fun. All right, so let's look at this sheet that corresponds with the unit circle. All right, so we've talked about this. I don't really care much about that part. All right, this bottom part is what I want to get to. Sine of 135. Radical 2 over 2. Okay. And we know that because the y coordinate at 135 is radical 2 over 2. Questions about that? Sine is the y coordinate. Remember, cosecant of 210. Cosecant is the opposite of who? It's the opposite of sine. What is the y coordinate at 210 degrees? Is it 1/2? Negative 1/2? So if I flip that, I get what? Yeah. Cosecant is the flip of sine.
Yeah, no. So we have to do this from here.
Pretty much. But you'll have a test where you won't be able to use the unit circle, so you have to memorize it.
So with the
radical 2 over 2, would that be still radical 2 over 2?
No, you flip it 2 over radical 2 and then simplify.
So
It simplifies just down to radical.
how do we do the 450 division?
450, find the coterminal angle. So subtract 360 basically. $90, right? What's the cosine of 90? 90 degrees. The x coordinate is? What's the x coordinate at 90 degrees? It's 0. 0. Tangent of negative 780. So that means you need to find the coterminal angle for 780. Negative 780. 300. All right, so we want to find the tangent of 300. So that's going to be you can't leave it like that. Simplify that.
And we can't use a calculator either.
No, you cannot. So this is y over x, right? Negative radical 3 over 2 over 1/2. What's 1/2 of 2? 1, so it kind of just cancels that out. Negative radical 3. Huh?
How'd you get that?
How did we get 300 or how did we get the 4?
How did you get upward?
Look at 300 on your unit circle and do y divided by x. Because tangent is y over x.
And how did you get 300?
The coterminal angle for negative 780. Remember, negative 780 divided by 300. Take away the negative part. Multiply by 360. Secant of 11 pi over 6.
That's 330.
Huh? 330.
Yeah, that.
11 pi over 6 at 330 degrees. What is your x coordinate there? Radical 3 over 2. So I need to flip that. Because it's secant. Secant is the flip of cosine. So 2 radical 3 over 3. If you put a decimal answer for any of these, I'm already wrong. All right, cotangent of pi. Cotangent of pi. Remember, tangent is y over x, so cotangent of x over y. So what is the x over y at pi is what? Negative 1 over 0. Undefined. Because you can't divide by 0. Portable. Can't divide by 0. Right?
Yeah.
So it's undefined. Sine of 4 pi over 3. So the degree is 240. What's the y coordinate there? Secant of 3 pi over 4. That should be 502 at 135. Okay. So what's your x coordinate there? Because secant is the opposite of cosine, right? So what's your x coordinate? Negative radical 2 over 2. So I'm going to flip that. Is what? Which is what? Negative radical 2. 2's canceled. So you said negative 2 radical 2 over 2. So the 2's cancel out. All right, tangent of 7 pi over 6. So 7 pi over 6 is where? Huh? 210. So what are your coordinates there?
gotta go over, right?
Negative.
Okay, what's your x coordinate?
Negative 3.
Radical 3, right?
What's your x coordinate there?
Negative radical 3 over 2.
What's your y coordinate there?
Negative 1.
So if you simplify this, that's 1 over radical 3, which is radical 3 over 3. Cosine of 5 pi over 3. What's the x coordinate at 5 pi over 3? 1/2. Sine of 7 pi over 2. Guess what you don't see? 7 pi over 2 only, do you? Alright, so we have to find the coterminal angle.
We're gonna do this.
No, don't convert to degrees.
Subtract 2 pi.
So we're going to subtract 2 pi. Instead of subtracting 2 pi, we're going to subtract what? 4 pi over 2. Right? So what's 7 minus 4? So your coterminal angle is 3 pi over 2. So sine of 3 pi over 2, it's negative 1. Common denominators, remember that. Alright, cosecant of 11 pi over 4. Oh, there is it.
Add 8.
Yep. So that's negative 3 plus 8 is 5 pi over 4.
Wait, run that back. 8 pi over 4. It's negative 3 pi over 4 plus 8 pi over 4 again. So you gotta add 8 plus 8 pi again to get a positive.
You gotta get a positive. So 5 pi over 4.
So basically you add
11, 8, negative 3, 8.
So it's 225.
Yeah. Alright, so the cosecant of 5 pi over 4, what quadrant are we in?
3.
Quadrant 3? Okay. So all of those are negative, so this has to be
Negative
what?
Radical 2.
Negative radical 2.
Oh, yeah.
Because it's cosecant, you have to flip it.
Oh.
Any questions?
So when it says terminal point at the top, is that just your coordinate?
Huh?
It says terminal point at the top of the sheet. Is that just your coordinate?
So what now?
What is the terminal point?
Oh, right here. That's what we're about to go over.
Okay.
Mr. Cobb, can you go back to the last one we did?
I'm so tired.
We're going to do those last few questions real quick and we'll be done. I wanted to make sure I got to these. That's why I skipped the first part first. Because these are the more difficult ones that you really need to know how to do. I don't want you guys converting the radians to degrees. I want you to know how to identify them based on the radians as well. Okay? Because some people will forget to memorize the radian stuff and they always convert it back to degrees and reference that. Learn the radians, please. Okay. Because if I take away your calculators, you're going to have a hard time converting back and forth.
Mr. Cobb, so what's your tips for learning like the radians that aren't 90, 0, 80, and 270?
Memorization. Yeah. There's a couple tricks, and I'll show you guys in a second. But this
It's like the second ones are easy.
probably won't remember these. All right. What is the reference angle for the angle of 240? Subtract 180.
60.
60. 60. What is the reference angle for the angle of 3 pi over 4? What quadrant is that in? Quadrant 2. So it told me to do what when the angle's in quadrant 2? 180 minus that. What is 180 in radians? Pi. So we're just going to do pi minus this, which is just pi over 4. What's 1 minus 3/4? 1/4, which is pi over 4. Does that make sense?
Yeah.
Okay. 1 pi minus 3/4 pi. If I have a whole and I take away 3/4, I'm going to left with 1/4. Basic fractions. All right. What is the reference angle for negative 730? The reference angle. What? That's the coterminal angle. The reference angle is who? So the coterminal is 330. What's the reference angle?
30.
30. What is the terminal point for the angle 510? The coordinate at 510. So find the coterminal angle and identify the coordinates there. So what's the coterminal angle to 510? 150. What are the coordinates at 150?
Negative radical s 3/2, 1.
Easy. So, like, is that gonna be a question on our quiz without a calculator or do something else?
Huh?
Is that like a question on our quiz without our calculator or
It could be.
answer?
Yeah, it could be. What is the terminal point for the angle of negative 9 pi over 4? I need to find the coterminal, right?
Yeah, so it would be
What's the coterminal angle for negative 9 pi over 4? 7 pi over 4. What do you notice whenever we do the coterminals for radian measurements? Does the denominator ever change? No. So just simply add or subtract 2 times the denominator. Because we took negative 9 and we're adding 8 to it, right? That gives us negative 1, add 8 again. That gives me 7. So that's what you're doing every time. You're adding 2 times the denominator to the numerator, or subtracting to find that coterminal angle. Okay? So 7 pi over 4. What are the coordinates at 7 pi over 4? That should be clearly and easy to identify because the denominator is a 4.
I actually get 7 pi.
Huh?
I get 7 pi.
We added the 8 pi over 4 twice. Now the next one is a little tricky. So all right, so example F. If you are at a terminal point negative 1, 0, and you move 7 pi over 4 units clockwise, what angle did you stop at? That is on the unit circle. Okay, so let's go to our unit circle. All right, so we're going to start here. So we're going to start here at negative 1, 0, right? How far did it tell me I moved? Which direction?
Clockwise, so it's a negative.
Clockwise, right? So I'm going this way.
Wait,
Okay. And it moved how far? What was the angle it moved?
315. What would be negative?
It moved 7 pi over 4 radians. All right. So if we start at 0, think of how far 7 pi over 4 radians. It didn't say I moved to 7 pi over 4. It said I moved that amount. Okay. So 7 pi over 4 is 3 quadrants and a half, right? Everybody see that? Because of 1, 2, 3 and a half. So I'm going to move this 3.5 quadrants clockwise. So 1, 2, 3 and a half.
Wait, you went clockwise
Because it told me to go clockwise. All right, so your angle is at 225.
So you just go the same amount of distance as it is from 0?
Right. What's that in radians though? 225. If your question's in radians, your answer should be in radians. I don't care if your question's in radians or answer in radians.
So would you give us like half credit if we put it?
I doubt it.
Just give me
Sure. Okay. Any questions about that? Yes. All right, so it told you how far to go. 7 pi over 4, right? If I angle 7 pi over 4, it's 315 degrees. So that's all the way around to this point. So that's 1 quadrant, 2 quadrants, 3 quadrants, and a half. So if we're starting at this point, -1, 0, we have to move that same distance. So we went 1 quadrant, 2 quadrants, 3 quadrants, and a half, 225. Okay?